So we lost the connection, internet connection momentarily, right? And we're going to work on lab number 7. By the way, can you hear me? I presume that you can hear me, right? Okay, good. Okay, thank you, Susan. Let me get my notes for lab number 7. I'm going to spend more time today doing the significant figures because I noticed that you folks are having difficulty with the significant figures. Here is the description for lab number 7. Very similar to lab number 5. Oh yeah, there's not lab number 4, lab number 5, okay? Very similar to lab number 5. Because we have 2 elements there. In lab number 5, we had 2 resistors. In lab number 7, we are going to have 2 elements as well. The difference is that one element is going to be, it's not going to be a resistor, but it's going to be a flashlight lamp. A flashlight lamp behaves differently from a regular resistor. The regular resistor, we call it an ohmic element. We call it an ohmic element because it behaves, because it obeys the Ohm's law, V equal to Ri. But not every element behaves, is an ohmic element. Not every element obeys Ohm's law. Okay, and that's the case of the flashlight bulb. Flashlight lamp. Okay, so lab number 4 was a circuit with a single resistor. Lab number 5 was a circuit with 2 resistors in series. Lab number 6 was a circuit with 2 resistors in parallel. And lab number 7 is similar to lab number 5, but important difference. We still have 2 elements in series. However, one of the elements is our ohmic resistor, your regular resistor that obeys Ohm's law. But the second element is a flashlight bulb. A flashlight bulb also has a resistance, but its resistance varies with the current in the circuit. All the resistors we have worked so far had a constant resistance with current, the so-called ohmic element or ohmic resistor. However, there are some electrical elements out there whose resistance changes with the current. Those are the non-ohmic elements, non-ohmic resistors. The flashlight bulb is one of them. And the flashlight bulb that I'm talking about is the regular incandescent light bulb. Okay, so incandescent light bulbs, they are not ohmic elements. Whenever you place them in a circuit, the current of the resulting circuit, the voltage, the resistance of the resulting circuit changes with the current, okay? That's what a non-ohmic element is all about. Okay, so here are the materials. Let me upload first the lab for you all. I'm going to stop sharing the screen momentarily. Lab, raw data, lab number 7. You. Okay. And make sure everything is correct here in this spreadsheet before I upload that for you. You could use more. Wow. You okay. You good. So let me pause the recording so you do not waste recording time. Now we can, I'm going to start sharing my screen again. I will go to my Google Drive and upload the spreadsheets. Here you go, group 1. Group 2. Group 3. Group 4. Group 5. Group 6. Group 7. Group 8. Group 9. Group 10. Group 11. Group 11. Group 12. Group 13. Group 14. Group 15. Group 16. Group 17. Group 18. Group 19. And last but not least, oops. Oh, okay, still didn't create group 20. Okay. Now we should all have a spreadsheet there for lab number 7. Let me know if you don't have it. And I will open one of them. Let's see, this one. Remember, this is a repetition of lab number 1, 2, 3, 4, 5. Lab number 5, with one resistor replaced with a flashlight bulb. Let's take a look at that flashlight bulb in the internet. It's incandescent. The flashlight bulb is an incandescent light bulb. It's not a diode. It's not a light emitting diode, LED. Flashlight bulb. Okay, that's how it looks like. Here is a LED lamp, okay, but the flashlight bulb looks exactly like that. You can see the resistance or the wire, the filament, we call it the filament of the light bulb right in here. And this resistance changes with the current. Let me clear what's going on here. I don't know. It looks like Chinese to me. Let's get out of here. Flashlight bulb. Let's go at Amazon. I want the Wikipedia. Let's see, flashlight bulb Wikipedia. Let's see if Wikipedia has Wikipedia. No, I want the flashlight bulb, not the flashlight. Okay, here you go. Here are the bulbs. Okay, the filament runs from one electrode to the other. One electrode is connected with the tip of the light bulb. The other electrode is connected with this side here of the light bulb. And then we have this black element that insulates this part from this part. Electrically insulates this part from, the tip from the body. That's how. Let's see if we have a better light bulb, flashlight bulb here. Doesn't look like we do. Let's go back to the images that we have here. Flashlight bulb. Well, you got the idea, right? So here you go. I like this one. Access denied. Oh, what a shame. Okay, so again, I'm going to repeat that for you, right? Here you go. You have this tip here, and you have this body of the light bulb, the flashlight light bulb. And those two are connected to the terminals of the bulb. And they are insulated by this black stripe that goes right in here in the bulb. See the black stripe here, this black stripe here, it insulates those two parts. One wire of the bulb is connected to the tip and the other one is connected to the side of the bulb. And we apply a potential difference between those two parts of the light bulb. Okay, here is the filament. It is this filament that has a non-ohmic behavior, and you're going to see this non-ohmic behavior whenever we plot the voltage against the current of the circuit. Let me show you. I'm going to go very quickly through the lab experiment and how we lab slides right in here. Number 7, light bulb. Okay, so what we do first we measure the resistance of the resistor and the materials, you know, and you're gonna have a resistor number 1, and the light bulb that also has a resistance that varies with the current. The first thing that you do, you measure the resistance of the resistor number 1. This is an ohmic device. This is a non-ohmic device. And that's exactly what this slide is telling you to do. And then we disconnect everything from the multimeter and it starts from scratch, right? We connect the light bulb in series with the resistor using a proto board, resistor, and light bulb. That's how is the representation of the light bulb. Notice that we have a circle. Every time that you see a circle around the device, it means that it is a light source. And this circuit we inherited from the sun, okay? The sun appears as a circle in the sky, and we borrowed this appearance of the sun in the sky as a way to illustrate a light source. An LED light source is also represented by something like that. What changes in the LED is whatever goes inside the circle. Those two devices are connected in series. Okay, and then we connect to our power supply. The light bulb is connected in series with the resistor. Close the circuit. Now we have the current flowing through the circuit. Here is the schematic. The electric schematic of the next. We set the digital multimeter to measure voltage. And we are going to measure the voltage across the whole circuit. Okay, across, that's what we are doing right in here. That would be the V total. Let's go back to that's the V total. We are going to also measure the voltage drop across the resistor, and I'm going to measure the voltage drop across the bulb, the flashlight bulb. I asked my students to measure, we invert the polarity to get the negative values, right? And let's not forget, in this meantime, we are changing the voltage from 10 to the lowest possible that we can get in our lab would be around 2.7 volts for the power supply. We measure the voltage and then we measure the current. In this table, what you see right in here, everything here is a measurement. It's a raw measurement. Here too is a raw measurement. This guy and those two are results, the results. The significant figures for those measurements are obtained from that table that I provided you, P07 sigfig.pdf, and the significant figures of those two columns are obtained from the summation rule and the multiplication rule. And that's all you have. There's no, there's a confidence level here that we have to worry about. And let's make notes, this one that I want, okay? Here are the materials, right? Digital multimeter, ohmic resistor, flashlight bulb, the incandescent light bulb, 2 black cables, a banana terminal, 2 red cables, a banana terminal, 2 alligator clips, power supply, and protoboard. Here are the instructions. Adjust your DMM to measure resistance, right? And so on. What you have to do? Plot V1 against I and plot VB against I. That's what you have to do first. So let's do that. V1 against I. Here you go. V1, I'm going to even to write it down, you know, plot V1 against I. How do you do? V1, I'm gonna, the cells for V1 is H10 through H19, yeah, H19. And I is I10 through I19. Cells, right? Cells. Here again, the cells is no longer VB. VB is gonna be what? VB is gonna be, no, it's not I, sorry, it's G. Here you go. G here. G. The current I. Here you go. The one is gonna be I. This one's gonna be I. V1, VB. VB is gonna be I10 to I19.